Well, hi everybody. I want to do a lesson online and I want you guys to learn it at home. And so then in class we're going to do lots of problems. But please learn from here. Okay, you can see that today we're going to be learning to graph and solve quadratic inequalities. Okay, in the form of these forms here. Let me go up to the board and I'll show you a little bit more. When talking about graphing these things, we can see that it's when we're doing the shading. We shade in a certain part. We chose a point and we saw if it worked in there. And if it works, then we shaded that part in. Now, when we work on the solving is a little bit more interesting because if, let's say we have this y here. We make this y 0 is going to be greater than ax squared plus bx plus c. Well, when is 0 going to be greater than this equation? Well, that's between here and here, or these points here. We could look at another situation. What if 0 was less than ax squared plus bx plus c? We wanted to know what x was going to be. Well, when 0 is the smaller number, it's going to be this shaded area over here, or this shaded area over here. And that's what we're talking about solving quadratic inequalities. Confused at all? Well, let's do an example where we graph it. All right, and maybe you'll be able to see a little bit more about what I'm talking about. When we graph stuff, we're going to graph it like we would any quadratic. We're going to take the y, but it's an inequality here. Y is greater than x squared plus 3x minus 4. How am I going to graph this? Well, I'm going to factor it to find the x-intercepts here. So I know that this is going to be y is greater than x plus 4 times x minus 1, because 4 times 1, negative 1 is negative 4, and 4 plus 1, negative 1 is 3. So I know that my x-intercepts are going to be at positive 1 and negative 1, 2, 3, 4. All right. I'm not going to worry about the vertex for right now, but I am going to notice that the A is 1, so I know that it opens up. So it's going to come down here somewhere, and I know I forgot to dash the line, because you have to dash the line when it's an inequality that it's only greater than or less than. It's not equal to, so I should have dashed the line. I made a mistake there. I know that I include 0, 0 here. So let's include 0, 0 in our function. So if I have put 0 is less than 0 squared plus, or greater than 0 squared, plus Forgot to make x equals 0.
4, what does that turn into? Well, that turns into 0 is greater than negative 4. Is this true? Yes, it's true. Therefore, this point is included. And I can shade in this part just like what I would any other one. And that's how I would graph a quadratic inequality. Now let's say that I wanted to graph a system, and we start with this one. We know that y is greater than or equal to negative x squared plus 4. If I want to graph that, I can take this and I can factor it, and I can say that's y equals greater than or equal to x plus 2, x minus 2. And I know right away that my intercepts are going to be plus or minus. But there's a negative sign here because I took out the a. So you know it's going to open upside down. So this one's going to open upside down here. Okay, now let's take the second one and let's graph that one. And we have y is greater than x squared minus 2x minus 3. Well, we know that we can take this and factor it and say that it is x plus 1 times x minus 3. So we know that it's going to hit over here positive 3 and negative 1. But it's going to be opening up because the a is positive. So we're going to open up.
Again, I forgot to make the line dashed.
And there we go. Now we do the math and we find out that it's included here with the purple. But for the yellow, it's included down here. So the part that matters the most is obviously the part that crosses. That is going to be the answer to this system of inequality.
Okay, now we're going to be solving equations. I hope that you noticed when I was graphing them, I made some mistakes. What was my mistake? I forgot the dashed line when there wasn't equal to. But never mind about that. It's a simple error. We're going to solve equations. When we're going to be solving this x squared plus x is less than or equal to 6, we're going to make it equal to 0 and we'll solve for x. And I'll get up to the board and I'll show you what this is all about.
If I actually wanted to solve for x here, I wanted to find out what values of x are going to work. I'm going to minus 6 from both sides. I'm going to change to x squared plus x minus 6 is less than or equal to 0. And I need to take a table first. We're going to use a table, just the basics, and then we're going to see a graph, and I'll show you on a data line what the answer is going to be for what x actually equals to make this all equal 0 or less than or equal to 0. Anyways, let's start off with x here, and down here we're going to have the x squared plus x minus 6. So when x is, let's say, negative 5, negative 4, we can usually want to take negative 5 to positive 5, and we'll say negative 1, let's have 0, maybe 1, 2, 3, 4, 5, 6. You can keep going on and on, but the x's you choose, and then we plug in a negative 5 into this x squared, and we get 14. We plug in the negative 4 here, we're going to get 6. We plug in this negative 3 for x here, we're going to get 0. Plug in the negative 2 here, we're going to get negative 4. Okay, this looks 0 and negative 4, so now we're becoming less than or equal to 0. This is good. Negative 6, again, we're going to have 0 is going to be negative 6 as well. We have negative 4, we have 2 is going to be 0. And then 3 will be 6, and if we plug x into here, 4 will be 14. Well, it looks like we found our match, and that's right in between here, when this whole thing is less than or equal to 0. So if we want to look at that, this is our answer. So when x is going to be, it's going to be between negative 3 and 3. So negative 3 is going to be less than or equal to x, which is less than or equal to 3 is our answer. We can even look at that on the number line, that we have negative 3 over here and positive 2 over here. Oh, the answer here is 2, not a 3. My mistake, that's a 2. 2 over here, and this is where our answer is. And we can even look on a graph. If we graphed this equation here, we have the 2 and the 3, which is actually, if this became a y, the 0 became a y, this would be the quadratic function. And you can see this is when the function is less than 0, is when the inequality actually works.
Let's see if we can do this a little easier. Let's see if you can do it before I can do it. Pause the video and try and do it before I do. You want to solve this if you can. Okay, you didn't do it? Then the algebra here you want to use, well, I can factor this function. If I factor this function, I'm going to get x plus 5 times x plus 1 is going to be greater than 0. Once I've factored it, I can easily graph the function. Or maybe through algebra you already know the answer. It's going to be about 5 and 1, or minus 5 minus 1, which will make it equal 0. So once we graph the function, we realize that it does go through negative 5 and negative 1. But it's when the function is going to be greater than 0. When is the function greater than 0? The function is greater than 0 over here and over here. That way, we know that the answer is going to be x can be greater than negative 1, or x can be less than negative 5, as you can see in the graph and from the algebra formula. That's it. I'll see you guys in class, and we can do some problems.